Yeah, hi all. So today we'll be learning about sorting algorithms. Okay, so there are a bunch of algorithms like bubble sort and insertion sort and all. So the first one will be the bubble sort that we'll be exploring. Yeah. First of all, what is sorting? It's basic simple that will be provided with an array. For example, here we have 7, 6, 3, 5, and 4. So what we have to do is basically sort it either in ascending order or in descending order. Okay. So that's our target. So let's first see how the bubble sort will help us to achieve this. Okay. So in bubble sort, what we'll do is let's take this array as 76534. We'll keep on swapping by comparing two values. For example, first we are taking the first value and the next value. So which one is greater? Now we are doing for, let's say, we want to arrange it in ascending order. Okay, 7 and 6. Which is greater? Obviously, 7 is greater, right? So what we want, we'll put all the greater values at the last and all the less values, the low values at the beginning. Yeah. So that is nothing but we are going to first swap it. So the array will be changed as 6, 7, 3, 5, and 4. Once we get this array, again, we have to swap it. By first, we have to compare, like if these two are matching our condition. So here what we get to know, 7 is still greater and 3 is less. So we're again going to swap because we want all the greater values at the last. So we'll be getting as 6, 3, 7, 5, 4. Again, we are going to swap it because here again the condition applies, 7 is greater. So we'll be having 6, 3, 5, 7, 4. And at last, one more time because 6, 3, 5, 7, 5, 4, 7, right? Clear. So what we did, we basically kept on checking, like if our number is greater. And if it is greater, we are just swapping it. We are moving it to the last point. Okay, so once we are done with this, what we'll do is this completely sorted? No, it's not. So we have to start it again. But here, what we need to take care is this last position is already fixed, right? Because we have compared with all the values and we got to know the last position is 7. So this is fixed. So next time when we are checking our loop, we did not take this element. So we need to like only check up to what number? 6, 3, 5, 4. Okay, so we have to run our loop basically minus one of this. Okay, so for that purpose, what I'll be considering is let's take the only loop as 6, 3, 5, 4. Even 7 will be present here, but let's try to avoid it. Like we will not write it and we'll just focus on this part. So here, again, the same logic applies. Is it greater? Yes. So we'll be doing it 3, 6, 5, 4. Is it still greater? Yes, it is greater. So we'll be still applying it like 3, 5, 6, 4. Is it still greater? Yes, because 6 is greater than 4. Then we'll be doing it as 3, 5, 4, and 6. So once we have received this, like reached up till this, now is there anything to compare again? No, this is the last value, right? So again, we are locking this value. We are not going to proceed with this. This is what we got final in our second iteration. Right? This is the final value and this position is locked. So when our next loop starts, we are just focused on this starting three values. So that will be like 3, 5, 4, 6, and 7 will be present, but we are not going to check it. Okay, because we know that we have already checked for those values and the positions for this are filled. Now we are only concerned with the starting three values. Okay, so let's first compare it. Now is 3 greater than like 5, 4? No. Is this greater? No, it is not greater. So this will be as it is 3, 5, 4, 6, 7. Then if this is as it is, then what we are doing is we are going to take this number, the next number, 5, and then we are comparing again. Is 5 greater than 4? Yes, it is. So then what we'll do is we'll keep it as 3, 4, 5, 6, 7. Now, as you see, this position is locked. We are not going to check for this and this. So even here, what we got to know, the fifth position is locked, right? And we are just left with these two values. Clear? So next time again the loop will start. I am writing here at last here. So final loop. Okay. So here what we'll be having, we are left with only 3 and 4. 5, 6, 7 are done. 5, 6, 7 are done, I can say. Now in this time, what we'll do is we are just checking for one time, 3 and 4, which is greater. Okay, it is small itself, so no changes. So we have 3, 4, 5, 6, 7. Clear? So I hope you have got the entire thing, how it's working. Now let's try to like analyze it, like how many loops it has taken, how many total iterations have occurred. So what is our length of array? So our length of array is somewhat 5, right? Good. So our array length is 5. Okay, 1, 2, 3, 4, 5. So for the 5 array length, how many times we are switching our main loop? This is our main loop, I can say. For how many times? This is the one time. This is the second time, third time, and the fourth time. So what we get to know, whatever is our n, right? Our main loop is running how many times? N minus 1 time. So it is running for 1, 2, 3, and 4. Clear? So when it is running for one time, how many times the sub loop is running? Now what is sub loop? This part, what you are going here, right? Swapping continuously. This is the sub loop or the loop which is helping us to swap. Now how many times this is running? Yeah, just try to count it. So let me use this color, and here we have 7, 6, 3, 5, 4. This was original. Then we had 6, 7, 3. Okay, 1, 2, 3, 4. Okay, first time it was ran for how many times? 4 times. Correct. Now, when it was in second iteration, now how many times it ran? 1, 2, 3. 3 times. Okay. Now, when it was third iteration, now how many times it ran? So it ran for just 2 times because these positions were already fixed. So it ran 2 times. And when it is fourth time, like the fourth loop, that is final loop, how many times it ran? It ran just for 1 time. That is, we are comparing just the first position, right? So it is running for just 1 time. Clear? So this is what we got an insight from this. Let me clear the unwanted part now. Now, once we have got this, so how to write a loop? That's the question. So we covered what? So what we got is, first of all, our main loop our main loop should run for how many times? Should start from 0 and run up to whatever is my n minus 1 time, right? Then inside this main loop, I have my sub loop for sub, I can say. And this is running for how many times? Yeah. This is starting from where? This is starting from 0. Okay. And whatever is my n minus 1. But this, if I do minus 1, this will be always 4. Right? So what I'll do is minus whatever, if I consider here x equal to 0, whatever is 0, this I have to put it here. So if you are expert in, let's say, pattern problems, what we have solved, I hope this is easy enough for you. If you are getting confused here, y, x and all, just watch the pattern problems once again and you'll get to know. Clear? So what I wrote, so it should start from 0 and go up to here. Whatever is my n, this will be 5. 5 minus 1 is 4. 4 minus x. Initially, x is what? 0. So it is nothing but it will run for 4, then it will run for 3, 2, and 1. Clear? So once we got our sub loop, now inside what we are doing, we are just checking the condition. We are giving an if condition and we are checking 2 values. Okay. And if this condition is true, we are swapping. Clear? So this is something like we can say our pseudocode or some general idea how our bubble sort is working, right? So let's try to run it. And what I basically have is I have a function which will display our array and a boiler code that is like it was present here already. Okay. So once this is done, now let me write a function for bubble sort. So enter. So public static method, I can say. Okay, I'm not going to return anything. I'm just going to manipulate it. So here I'm passing an argument as a reference. I hope you remember what is passing by reference. So here I name it as bubble sort. Okay, and do I need argument? Yes, I need the parameter. So int r. Okay, cool. So let me first write my main loop. So that is for start with end where it is x equal to 0. equal of 0. Okay, go up to where? Go up to my array dot length. Okay, so it is array dot length means if I do, it's already like if array length is 5, okay, it will only run up to where? 4, index 4. Okay, that is already by default. But we have what I'm doing is I'm doing -1. Okay, so this will, if there was no -1, this will run for 5 times, but as I did -1, so it will run for 4 times. And now what I'll do, x plus plus. Clear? So once I'm updating my x, then I'll go inside, and my inside loop is what? Let me write for in, and here I'll say y equal to, let's say we should start with 0 again. Okay, and y less than, what it should be less than, my n is what? Array dot length. Okay, -1, here, minus x. Okay, once I've done this, and I have to keep on incrementing my y. Clear? And here I have to check the condition. So what is my condition? If my array of y, okay, presently y is nothing but the inner subloop what we are checking, right? Each element y is, let's say, greater than array of y plus 1, so it will obviously take 1 extra. Then what you do is sorting. Like for swapping, what we'll do, we'll create a variable int temporary variable equal to, okay, let's initialize it just. So here what I'll say, my temporary variable is initially array of y. Okay, then my array of y is being updated as whatever is present in array of y plus 1. Okay, and my array of y plus 1, okay, which is the next value, is updating with the previous value, or that is array of y. Clear? So basically what I have done is I swapped it, right? So once I have done swapping, so yeah, that's it. So let's try to test it. So before testing, what I'll do is I'll pass my array here, bubble sort array. And as it is passed by reference, so it will be automatically manipulated all the inner values. And next what I'll do is I'll display my array. So I'll call display array function, and let's check it. So let me clear all drawings and run it. So if you see, the values are, oh, okay, slight mistake, I guess. Let me check my swapping. So array of y. Okay, here I'm swapping y itself. Like actually it should be 10. Slight mistake. So yeah, and now it will work fine. So check it. So yeah, 3, 4, 5, 6, 7. Clear? If you see here, we have sorted our array completely fine. Clear? So I hope there won't be any doubts. So if we try to see our time complexity, our inner loop, like our main loop is running for n times, and our sub loop is also running for n times. So this will be like n square. Correct? Okay. So this is not a good time complexity. So we have better, what I can say, we have better algorithms with good time complexity, but we can optimize our code. Okay, for let's see a code here, for example, and now I already have a array 1, 2, 3, 4, 5 in this form. Okay, so this is what? This is already sorted, right? Am I right? So it is already sorted, and this is the best case scenario. So whenever you are calculating the time complexity, like there will be like best case and worst case scenario. We'll discuss this in future, but now best case instance, we did not manipulate anything. It is already sorted. So even for like this type of arrays, this algorithm, like bubble sort, is going to take how much time complexity? O of n squared, right? Because it is going through each item by item in sub loop, and it is going to check this condition, right? But there is a way through which we can optimize our bubble sort, and through which we can reduce our time complexity of O of n, right? And this is for only sorted array. Okay, sorted array, or I can say best case scenario. So how will we do that? So for that, what we have to simply check is like if this condition we have done, like if we have swapped, okay, what we are doing, if we swap, then only we are like going and checking it. Yeah? like if we are not swapping in our first iteration itself, if there is no swap occurred, because we are going to check continuously, right? And if there is no swap occur, that means these are already sorted and we need not check for next, right? So we simply need to have something like a switch button or something which will help us to check if this condition has been like activated or not. Okay, so for that, what I'll do is I'll create a button variable or a switch variable, something like that you can do. So let me say here int let's say button equal to, I'll name it as, initially it is false. So okay, so that means or I can simply name it as swap, that will make much meaning. And sorry, it's a boolean. Okay, boolean. And here, if it is swapped, then what I'm going to simply do is I'm going to change my swap variable as truth. Clear? So what I have done, I simply created a variable for my sub loop and I named it as swap, and I said initially it is false. There is no swapping occurring. But inside this loop, what I have done is if condition, if this condition is activated, then obviously that means here swap is taking place. So I changed it to swap. Okay. Now what I have to do is inside this, like after this for loop, here I'll simply give a small condition saying if not swap. Okay. If not swap. Okay. So why I give not? Because like let's say if it is swap is equal to true, and if it is true means what should happen? I should check once again, right? So if I want to check it once again, then this condition shouldn't be executed. So what I said, true's opposite will be false. So for that reason I give not true. Okay, that will become false. But in case if this condition never got executed, then initially swap is false, and not false like not, and writing false in front of will become true. That means this condition will be activated, line number 21. And here what I'll say is simply I'll say break. Clear? So here writing the break will let us will remove us from the main loop. Okay, we'll be popped out from our main loop. And that's how we'll get the time complexity as O of n. Okay, so this will work best for already sorted arrays in our best case scenario. So just a little bit updated version of bubble sort is known as selection sort. Okay, the issue with bubble sort was the lot of swapping was happening. So to avoid that, what we can do is selection sort. So let's take the same array, that is 7, 6, 3, 5, 4. So here by default, what we'll consider is our whatever is the first element is the minimum position. Okay, so here we are considering 7 as our minimum position. So with this, the rest part, whatever is there, this will consider as an array. Okay, through which we are going to loop, and the minimum one among this will be swapped with the minimum position. So here minimum is 3, so that will be swapped with the 7. So for example, this will become in our first iteration, this will be swapped like 3, 6. Then here it will come 7, 5, 4. And if you see now, this position is fixed. Okay, 3 is fixed. We are left with only 6, 7, 5, 4. Okay, so once we are left with this, when our next iteration starts, now what we are going to take, we are going to make this as our minimum position 6. By default, we are making it as our minimum position, and we are going to run with what? This array 7, 5, 4 is our next array, right? So if we try to write it, then we'll be having 3. Then this here will get 4 as our minimum, so it will be swapped by like 3, 4, 7, 5, 6. So this is being swapped here. Yeah. So now what are the fixed position? 3 and 4 are fixed position, right? Okay. By default, what is our initial position now? 7 is our initial position, right? And we are left with what? 5 and 6, through which we have to check which one is minimum, and that we have to swap, right? So we got to know that which is minimum in this. 5 is minimum. So that will be swapping with 7. So we are left with like 3, 4, 5, 7, and 6. So these parts are fixed. This is done. We have 7 as our initial position again, and 6 is there. So finally we are comparing and we get to know that this is the largest. So we are swapping. So again, from this, the final, this will be 3, 4, 5. And here it will be 6 and 7. Yeah. So that's it. So if we see now how many times swapping occurs, like if you compare to bubble sort, here the swapping was very less, because here what we are doing is we are just comparing. We are finding out minimum. Always we are trying to find out the minimum one in a given sub array, I can say, or like splitting the array. And from that, we are just shifting it in our main loop. Okay. From that, we are just swapping in our main loop itself. Okay. So let's try to write the code for that. So here I'll say public static method. Okay. Void. Okay. This is selection sort. Selection sort. And we have int array, control C as our parameter. Okay. Then what I'll start is I'll start with my loop for int x equal to 0. Okay. And go up to where x is less than array dot length minus 1. Y minus 1, x plus plus. Okay. Let's try to count how many this we have. Here we know the length is what? 5. And if we check our loop, 1, 2, 3, and 4. Why didn't we went up to fifth time? Because already when we do the last iteration, there is no need to compare like 7. Is it this? Because there is nothing here to compare. And this is always like a last position, right? So we need not require the last iteration. So we are just running for 4 times. Okay, so what I have, array dot length minus 1, right? So once I have written that, so I'll write my inner loop for int y. So what should be my y? Obviously, when it was 7, we are starting with 6. When it was 6, we are starting with 7. So whatever is my x, right? What will our main loop give? Yeah, what will our main loop give? Our main loop will give us this point, 7, 6, 5. Okay, again it gave us 7, 7. So this is what we are getting from our main loop. Okay, these values. So whatever are this main value plus 1 we want. Yeah, so here I'll write whatever is my x plus 1 I want. And where I have to go is I have to go up to y less than array dot length. Okay, then what I have to do is y plus plus. Yeah. And once I done this, here I am simply checking. Okay, I didn't create a minimum position as a variable. So let's say int min position is equal to, by default, we are giving it what? X, right? And here I am going to put a condition. So if there is any situation where array of min position, okay, is greater than, let's say, array of y, if this ever happens, okay, if what I'll do is I'll update my min position equal to y. Okay, here I'm not swapping, I'm just updating my values. Once this entire loop is over, that is my entire sub loop, before going to my next main loop, here what I'll do is I'll do swapping. So I'll say int temporary variable equal to whatever is my array of x initially. Okay, then I'll update my array of x equal to whatever is my array of minimum position that I'll get. Clear? Then I'll update my array of minimum position back to my temporary variable. Right? So yes, that's it. And here I have already updated as selection sort. So let's run it. Clear. So we have 3, 4, 5, 6, 7, which initially we had this, and yeah, so we sorted our array. Yeah. So if you see here, we are not continuously swapping. Our swapping is outside our main loop. So here swapping is happening how many times? Whatever is my array dot length, right? Minus 1. That many times our swapping will occur. Clear? The next algorithm is known as insertion sort. Okay. So here the main logic is like if this is a given array that is 7, 6, 3, 5, 4. We'll be basically first dividing like this array. We'll be treating like the main logic I'm saying is we'll be having somewhat called as sorted array. And here we'll be having unsorted array, right? What we'll be doing is we'll be picking one element of this unsorted array at a time based on iteration. And we'll be just putting it in our sorted array. Here also there will be few data. We will see where is its proper position. And we are just going to put it in that position. Okay, so this is the main logic here. Now, if we try to check it, how it works for this. So let's assume by default, what we'll be saying is that our first element itself is a sorted array. So we are considering this is a sorted part. Okay, here we are not like creating any array, but we are treating itself like it's a sorted part and unsorted part. Okay, so here first we have 7. So our next element, like in this is like, let's say unsorted part. And here we have 6. Okay. We are taking this 6 and checking in this, where will this be fixed? So when we compared with our 7, we got to know that 6 is less. So it should come here. So what we did, we just shifted our 7 back and we'll shift our 6 here. So what we get from this is we get 6, 7, 3, 5, 4. Okay, now the sorted part is what? This much is sorted part, this much is unsorted part. Okay, so once this is unsorted part, we will take our next element, that is 3. Once we take it, we will be checking with our first 7. Now, when we compare, we got to know that 7 is still less. So we'll be shifting it back. Okay, where is this 3? Like we'll be storing this 3 in some variable. Let's say this 3 is put in some variable. Now it is stored here. And 7 will be placed here in the 3's position. Then we'll compare this with 6. Now 3 is again less, so we'll shift 6 here also. And finally, there is nothing to compare, so we'll be putting our 3 here. So from this, what we got? We got our final again one this, that is 3, 6, 7, 5, 4. Okay, so this much is sorted part and this much is unsorted part. Now here what we are doing, here are again next, this is 5. Yeah. So this we have to do. So this I'll put it in a variable. Let's say 5 is a current variable. Here I have stored 5. First I'll compare it with 7. Now 7 is obviously greater, so I'll push it back. So it will occupy the 5's place. Then I'll compare it with 5, this 6. Then even this 6 is greater, so I'll push it in 7's place. And then I'll again at last compare it with 3. Now 3, if the condition is not satisfied because 3 is less. So what I'll do, I'll push this 5 in the 6th place. Okay, 6 is already pushed here. So the final outcome of this will be, we'll be getting an array as 3, 5, 6, 7, and at last there will be a 4. Now this much is sorted part and this much is unsorted part. Right, from this we are just going to pick this one. This is the one that is left. We are storing this in, let's say, one current variable. Okay, here the 4 is stored, and here we are comparing each element time by time. First we are comparing with 7. 7 is like greater, so we are shifting it back. Okay, so like here our array is continuously being updated. Okay, so for example, now what will happen? The 7 will go in this position. So we have 7. Then it will compare with 6. Now again 6 is greater, so we'll put it in 7's position. So we have 6. Then we'll compare with 5. Again we get to know that 5 is greater, so we'll put it in 6th position. So here it will be 5. And finally, when we compare it with 3, we get to know that 3 is less, so we'll put it in here. Okay, so the final outcome of this will be somewhat 3, 4, 5, 6, 7. Clear? Okay, so let's move on to the coding part. So here I want first of all a loop for int x equal to, I'm starting with 1 because the first index, that is 0, I'm considering it as by default it is sorted. So for that reason I'm starting it with 1. Okay, and I'm going up to where it should be less than array dot length. So I'm traveling the entire list at end, and x plus plus. Great. That once I enter the loop, what I said first is that whatever the element, that is now we are taking the sixth element, then we'll be taking the third element, that is nothing but our present x. So that what we have to do is we have to store it in a variable, right? So let me create a variable. So int current equal to my present array of x. Great. So now what I did is to took that variable. For example, now what is x equal to 1? That will be like 6 array, that will be 6. And that I have stored it in current position. Clear? Then what I'll do is int previous point I'll say. So I'll say something as previous. And what should be this previous? This should be -1 to go into our sorted array. So whatever is my, or instead I can say it as x minus 1. We are just talking about index. Correct? So x minus 1 is what? 0. So our 7 by default, when we start for the first time, previous is nothing but it is the index of this 7. Clear? Then I'll write a condition. Here I'm using a while loop because this is conditional based loop. While what I have to do is we'll be traversing in the reverse order, right? We'll be going like, let's say when we reach up to like third, and let's assume this is sorted. So we are traveling in reverse order. So somewhere we have to do subtraction. And when we are doing subtraction, there will be a point where it will reach to the 0. So here I'll just give a condition saying that if previous is greater than or equal to 0, then only this loop should work. And there is one more condition what I have to give. That is, if my current, whatever I have stored, that is array of x, okay, if my current, okay, is less than, okay, is less than my array of previous, okay, is less than my array of previous, then only enter into this loop. Okay, once it has entered into this loop, what I say, whatever is my array of previous plus 1. So here what I am doing is I'm just shifting one element back. Okay, if the condition is satisfied, so what we are doing is shifting one element back. If you are not getting this, we'll just try run it once and you will get to know it one. So here I am shifting it back. So array previous plus 1 equal to whatever is my array of previous. Okay, so this is nothing but x minus 1. For the first time it will be x minus 1, and this will be like x. So whatever is in the x minus 1, we are shifting it to x plus 1. So this is something like shifting backwards. Okay, and just this much is not enough. What we have to do is we have to update our previous, otherwise this will be an infinite loop. So I'll say previous minus minus. Clear? So once I have done this, okay, then at last what I have to do is I have to put my element. For example, when I will be taking, let's say 3, when I'm checking it in sorted array, I have to, once the conditional part is all done, what I am doing is I am fixing it in a relocating in its correct position. So for that point, what I say is array previous plus 1, okay, equal to my current, which I have stored in a variable, right? So this much itself is the insertion sort. Okay, I hope it's clear. Let's first test it. So, okay, insertion sort has already been returned and we are displaying the array. So let's run and check. So if you see, my present array was somewhat jumbled. And if you see the final output, it is 3, 4, 5, 6, 7. And if we check the insertion sort, look, so yeah, everything is working fine. So our next algorithm is sorting algorithm. Yeah, it works best. Like this is mainly used when our values present inside our array is less. For example, here, what's the value? The values are 7, 6, 3, 5, 4. Okay, and the lowest, like the max value here is what? 7. Need not worry about the quantity. Like here, even if the array length is 100 or 200, like that's fine. But the value inside that shouldn't be that great. Okay, so if you ask me why, because our main logic of the sorting algorithm is based on these values itself. Right. So let's try to check it, how it actually works. For that, what I'll do, I'll just try to duplicate this values. For example, let's say 4, 3. So here, let's say now we have an array. What's the first array that we are given? We are given with 7, 6, 3, 5, 4, and 3. Let's say that, and let me remove 1, 4. Clear. So 7, 6, 3, 5, 4, 3. Okay. So if this is our array, what we are going to do, our first step is to find out the max value. Find out max value. Okay, let me write it a bit adjacent here so that it's better when we are coding. So here our first condition is to find out max value. And if we see in this, what we'll get, our max value is 7 in this. Okay, that is present in the first index itself. Clear? Then our second step would be to create an array. Okay, let's say the array name is temporary array. We can say something like that. Okay, so let me say a temporary array. Okay, and its length should be nothing but the length of this 7. Okay, plus 1, because the index also has to be included. So it has to have an index up to 7. So this is nothing but we are creating an array. So 0, 1, 2, 3, 4, 5, 6, 7. How did I get 7 here? Because we had our max value as 7. So once we have our max value here, what we are going to do is we are going to refer our index and our values. For example, we are going to check if 0 index, if this 0 is present in our this array, that is the value, if the value 0 is there. It's not there, so we are temporarily like putting it 0. Then is 1 present in this array? The index, like the 1, this value is not present. So here also it will be 0. 2 is not present. 3, is there a 3? Yes, we have found out 1, 3. So we'll update this as 1 because there is 3 value present. And again, if we go forward, we are finding 1 more 3. So that's why we are again removing this 1 and we are updating it as 2. Similarly, then we'll do for 4. Okay, we found out 1, 4. Then we found out 1, 5. Then we found out 1, 6 and 7. Okay, so it will be 1 and 1. Clear? So basically, what did we found out here? We found out that our particular index is like, is it present in the array? And if that index is present, how many times it is present? Okay, like for 3 was present for 2 times. So that's why we stored the value here as 2. Clear? So once we have achieved this task, our next task is to again update our original array. Okay, now we are going to update our original array. So how we are updating here is that we are basically going through this loop, the temporary loop. Okay, and wherever we find any values, okay, that we are storing it in our array. So if you see, our first we are getting 0. So whenever there is 0, we are just ignoring that. Okay, let's put a condition where we are ignoring zeros. Then as soon as I get something which is greater than 0, I'm storing this index as a value in my arrays. So first, let me create an array. And its default, how many are there? 0, 1, 2, 3, 4, 5. So it's having 5 index. So let me name it like 0, 1, 2, 3, 4, and 5. 5 index. Okay, and when I iterate through this temporary variable like array, I found out that in third index, I have 2 as value. So this, whatever is the index that I'm storing as a value in my 0th position of the array. Clear? So after I store this, what I'm doing, this 2, whatever was there in the temporary array, the value, I'm removing this and I'm updating back to 1. Clear? Then once I update back to 1, again, I have put a condition to check if it is 0. So it's not yet 0, it's still 1. So what I'm doing, I'm again updating this value, that is the index, as the value in my array. Clear? So once I do this, now it's completely again removed and it is updated as 0. Now it goes to the next number 4, and 4 is greater, like it is having a value which is greater than 0. So we are removing this, putting 0 and updating here as 4. Same thing with the third, like here we have now file, like there is the one value present here, we are removing this, updating as 0, and here also we are putting the index of this, referring it here. Similarly, we are doing it for 6 and 7. Okay. If there were like multiples, like if it was something like 2 here, then we could have updated 2 times 6. Yeah, but there is nothing like there. So we did not worry of that. Okay. And once we do this, so this is our final output. At the third step, we get our array, which is completely sorted. Clear? So I hope you have understood it. Let's try to code it so that it's better in understanding. And let's do it step by step itself. So I'll keep this note adjacent so that we are referring which part we are doing. So my first part is to calculate the max value. So let me first create the function public static. I don't want to return anything, so void. And my function name is like counting sort, something like that. And yes, I want the argument, which is like int array of square brackets. Once I have done that, okay, what is my first step is to get the max value. So I'm iterating like I'm putting a loop int x equal to 0. Okay, and go up to where x is less than array dot length. Okay, and after that, keep on updating my x. And once this is done, like it go inside this. And here, what I have to find out is largest value. So for that, what I want is a variable int, let's say largest value equal to, let's say initially it is integer dot min value. Look, we had done this multiple times. So yeah. And then here I'm putting a condition. If my largest, or if let me first put array of x is greater than my largest value, if this ever happens, okay, go inside this if condition and update my largest value equal to whatever is my array of x. Okay. And this is how we get the largest value. Okay, once we get the largest value that is stored in this variable, our first task is done, our first step. What is our second step? Is to create a temporary array, which is of the length of the largest value. So let's say temporary. Oh, let's say put int temp square brackets equal to new. What it is? Int square brackets. What should be the length? Length should be the largest value. But just to note here, what is largest value now? Largest value is 7. But when we say 7, okay, when we say the length is 7, the index is only up to 6. But our whole algorithm is dependent on these indexes, and we want the index up to 7. That is the largest value. So for that reason, what I'll be doing is I'll be adding +1 for this largest value. Clear? So here I will be doing +1. Okay. If I didn't do this, then my index will be up till 6 itself. But I want my index up till 7. That is up till my largest value. So for that reason, I had done +1. Clear? Once I do that, what is my task here is to store the values here. So for that, what I can say for int, let's start with x equal to 0 and go up to x less than array. Yes, it makes sense to use array dot length. Okay, x plus plus. Okay, now there may be a few confusion, like why did you take temporary temp dot array? Because when we create this step in line number 64, so by default, if you try to print this temporary array, everything, all the index will be having a value of 0, 0, 0. Okay, so these values are already filled, like this is already filled. We are concerned only about the one which we have to fill greater than 0. So for that reason, what I do is I'm only concerned about this part, whatever I want to operate. So for that reason, I have chosen array.length. I have to run up to array.length. Clear? So once that is done, now what I have to say is, let's first say array of x. What will this give me? Okay, what will array of X give me? Array of X will first give me 7, then 6, then 3, then 5, 4, 3, right? But what I want to update, like whatever is this value, it's related index. Okay, like if you are still confused, now array of X is going to give me what? Let me just clear a bit here. So we have, okay, so here it was 6, and I'm repeating again. Array of X will give me what? It will give me 7, 6, 3, 5, 4, 3, right? And what I am interested in, my temporary index of 7, okay, should be updated with how many 7s are there. Clear? So how can I say temporary of 7? That I can say it like here I already got 7. So here I am putting this in a square bracket and I say 10. Okay, so this will give me that particular index of a temporary array. And equal to what I have to put, I did not put equal to, I have to just update the values. Clear? So initially temporary of 7 was what? 0 before the for loop. Now once it has come here, so here array of X will give us 7 and temporary of index 7 will be updated from 1. So we'll get it as 1 in this position. Okay, so our first value that is updated in here is this. This will be updated first. Then what is 6 is there, right? 6 is there. So our next value is updated. This will be updated. Then 3 is there. So this will be updated. There is a lot of mess here. But yeah, I hope you are understanding. So 3, this will be updated next. Clear? So in that way, what we are getting is we are getting our complete temporary array. Okay, once we are done with that, we have to move to our next step. That is our third step. Clear? So in my third step, what I have done is I am updating back my array. So let me first write the loop for that. For int, let's say X equal to 0 and go up to X. Okay, now what should I use? Should I use array.len or temporary.len? So here I have to use temporary.len because I have to know the values of this present here. Yeah, so I'll put a temporary.len, but later I'll put a condition which will ignore all the 0 values. So temporary.len. Okay, and what you do, X plus plus. Yeah, so once this is done, that is basically we are using this, it's going from 0 to 7. Yeah. Now, what next is we have to update our array. So let me put array. But I can't use X now because it will give us an error saying that index out of range. For that reason, what I'll do is I'll create a separate variable here. Let's say int, let's say index, and I'll initialize it with 0 to start with this. And then what I can use here is a condition first of all. So I'll first put my condition while I'll put a condition saying that array of X, if it is greater than 0, then only come inside this loop. Let me clear this line number 72. Okay, if it is greater than, then only come inside this loop. So by default, it is going to ignore this 0, 0, 0, starting 3 zeros of temporary array, and it is directly going to the third one. Okay, once we reach to that point, then what's the next step is my array of index. So this is nothing but array of 0 because initially the value is 0 there, equal to what I have to update is the index here. Okay, so if you are, this is like a bit unique algorithm, I can say. Here what we are updating 3 is what? The index here, and this is referred what as X. Yeah, I'm just highlighting once again. This is referred as X, and this we are storing it in 3. Clear? So let me put that here. So I'm updating it as X. Clear? Once I have done that, my next basic step is, which I should not forget, is I have to make my index plus plus so that I move to the next point like 1. Then there is one more thing to update. That is, I have to make sure whatever is my array of X is subtracted, like minus minus. Clear? because in case now here it is 2, right? 3 are present 2 times, so it is present 2 here. So I am subtracting it and I am checking if again checking if it is less than 0. Okay, like greater than 0. If it is like less than 0, I am stopping this while loop. Clear? So in this way, what happens? It continuously checks and it will fill at this array. Yeah. So that's it. Let's check it. So let me write a step here saying counting sort array. Okay, that's cool. And let's run it. Okay, we got an error saying index 7 out of bonds for length 4. Okay, let's see why. So what I have to check, array of x, it's not array of x, it's actually temporary of x if it is greater than 0. So this is not greater, so not greater, not greater. And from here I have to check. So it's basically what? Temp and not array. So this is my first mistake. Let me rectify it. So I'll update this as temp. Good. Once I have updated my temporary of x is greater than 0, then what I am updating? My array of index. Okay, this part is correct. Array of index, because yes, equal to x. Okay, that is correct. Then what I am doing? Index plus plus. Yes, absolutely fine. And array of x. No, this is not again array of x. This is temporary of x. Temporary of x minus minus. Clear? Okay, simple, very silly mistake. That is, here I forgot to put the quotation marks, so like curly brackets. So it's actually, this step should be inside this. Okay, it happens in flows. So yeah, yes, there was just a silly mistake that after if I had terminated instead of like putting the curly brackets. So if I check it now it should work properly. And if you see 3, 3, 4, 5, 6, 7. Okay, what is this 7? I just tried to print its largest value and check. Great. So if I run once again, and you will be able to see we have got and sorted it. Clear? So yeah, that's it with sorting algorithms. And it's, so what all we have done. So let's say bubble sort, selection sort, insertion sort, and counting sort. Okay. Apart from counting sort, the remaining 3 which we had discussed, it all take the time complexity of O of n squared. Whereas in counting sort, it somewhere goes up to n, O of n, right? And it's not necessary when you are doing projects like to type again your own sorting algorithms and all. What you can do is you can use the by default sorting this function that is present in Java. So that is nothing but you can use it by saying arrays dot sort, and here you have to pass your parameter as the array which you want to sort. And let's comment this part, the one which we have created, and if we run now, we'll be still able to get it in sorted form. Clear? Cool. So I hope you have got till here. And if you have any doubts, any questions, do let me know in the comments. And yeah, catch you in next class. Bye.